Hello viewers, in this video we are going to discuss about the projectile of motion. Under this, let me see one problem on this. Look at this problem on the screen. A soldier fires a bullet at an angle of 30 degree upward from horizontal from his position on hill to strike a target which is 61 meter lower than the position of the soldier. The initial velocity of the bullet is 91.5 meter per second. Calculate, the first one is maximum height to which the bullet will rise above from the horizontal. Then second one is the actual velocity with which it will hit the target. The last question is the total time required for the flight of the bullet. Right. See, look at this problem. Here the soldier is standing in the uphill and fire the bullet with a velocity is u. The bullet is traveling with a velocity u with an angle alpha to the horizontal. Now we resolve this initial velocity u in terms of horizontal component and as well as vertical component. The bullet is traveling and follow this path ABC. The A is the maximum height attained the bullet, then the bullet is fall down and travel through a point and hit the target C. So we need to find the maximum height traveled by the bullet from the horizontal position of the soldier. This is the first question. Right. Let me see. Here the initial velocity is given in the problem is 91.5 meter per second and the inclination is alpha, which is also given here 30 degree. There is 30 degree from the horizontal. Now as I already told, we resolve this u into horizontal component as well as in the vertical component. Horizontal component is ux, whose value is 79.24 meter per second. And the vertical component of velocity uy is value is 45.75 meter per second. Right. Now we will find the h max, that is the maximum height traveled by the bullet. Is we know that formula which is arrived just before the previous video, u squared sine squared alpha divided by 2g. Substitute all the necessary value here and find the h max value. Then coming to the second question, the actual velocity with which the bullet strikes the ground. Let v is the velocity of the bullet strike the target at C, where v is the final velocity. So this is also inclined. So we can resolve this inclined velocity into two components. One is horizontal component Vx and vertical component is Vy. The horizontal component of velocity is constant throughout of the flight of the projectile. So let Vx is equal to u cos alpha, that value is already arrived 79.24 second. Only thing is we need to find vertical component of the velocity because it's varying continuously. To find Vy at the target C. So consider upward motion, downward motion of the bullet from A to C. At A the initial velocity equal to 0. So we can use the equation of motion, second equation of motion, v square is equal to u square plus 2as. So in this the bullet is traveling towards downward, hence we use plus 2g instead of a, and instead of s we used here h. So the formula becomes v square is equal to u square plus 2as, and h max is equal to 106.5, and whereas the distance of the vertical downward point is, that is from point B to C is 61. So the total height is equal to 106.5 plus 61 is equal to h. So substitute this h here, and initial velocity is 0, and we will obtain the final velocity, that is a vertical component of velocity, v is equal to 57.37 meter per second. Now we can estimate the resultant velocity, that is equal to root of vx squared plus vy squared. That value is 97.83 meter per second at C. And also the inclination theta is equal to tan inverse of Vy divided by Vx. That value is equal to 35.9 degree. And the total time is equal to T1 plus T2, where T1 is not equal to T2 because this two times need not to be same. Hence, we need to find T1 and T2. So, let me see first T1. So, here V is equal to U plus AT. Here we substitute G instead of A, and also we use negative sign because the bullet is traveling upward direction, that is against the gravitational force. So, hence we consider minus sign. So, here the final velocity is 0 because the bullet is reaching the target at A and attain the velocity is 0, hence V is equal to 0. The initial velocity is 45.75 and minus 9.81 into T1. From this equation we will find the T1. Similarly, let me find the downward motion T2. Here we use the same equation, V is equal to U plus AT. Here A is replaced with G with the used positive sign because it travel towards center of earth, hence A is used as a positive, that is G is used as a positive value. So from this equation, the initial velocity at A is equal to 0, the final velocity Vy is taken as 57.37. Substitute the value in this equation, we will find T, that is equal to T2. So now you add this T1 and T2, we will get total time of the flight. Thank you.